Hello, Mr. Stone here, and today we are going to be looking at another way to solve systems of linear equations. In this particular case, let's look. We've got three equations here that have a total of three variables in them. We have some methods that we can use to solve those, but our new one today is going to be using this new thing called Cramer's rule. And how does that work? Well, the first thing you need to do is to turn the equations into a matrix. In this particular case, we can basically break down what we've got. We've got all of our x's here, and that's going to go into our first column of a matrix. We have three equations and three variables. You do need to set this up so that you've got all of your x's, y's, and z's in the column of the same variable. If you do not, this will not work. So it is very important that you do that. Remember that if you don't see a coefficient, you can assume that there is a 1 or possibly a -1 in front of it if you're subtracting. But that gives you all that stuff over here. You have also a fourth, in this case, fourth column that is going to be what I call your constant column. There are no variables over here. This is just constants. So that is, you set everything equal to that, and we've used it to solve for these equations in the past. We're just formatting it a little bit different. So the important thing, again, is to make sure that you have all of your x's and y's and z's, your three variables, in columns that are only those variables, the coefficients for each of those variables. Again, the values they put in here are the coefficients of what is for each of the respective variables. We're going to save this constant column. We're just going to kind of set it off to the side for right now. First thing you need to do is take the determinant of the matrix that you've got. So I showed a lot of work right here. We've done determinants before. I'm not going to go over the full details, but just showing enough here that you can pause your screen if you like to review determinants. We've got another video on that if you need to review. But long story short, this is the same, I'm calling this D, by the way. This is the same matrix that we set up originally from our equation, from just the variables. Again, there's your x, your y, and your z coefficients. And we get a determinant of 15. And we're going to need to save that for right now because we're going to come back and use that later. Alright, so now we've got a determinant for our main matrix, which is this guy right there. Now, find the determinant of the matrix when the constant column is placed in for a variable column. This is where it gets a little bit weird, but not too weird. So basically we're going to take this and we're going to plug it in for whichever variable that we want to solve. So we said that this first column was all of our x coefficients. So I'm going to scratch all those out, knock those out, and replace them temporarily with the constant column. And it's going to look something like this. And why are we doing this? Well, we're going to take the determinant of what we are, the matrix that we now have. So again, we've done determinants before. I'm just going to show very briefly what's up there. I'm not going to talk through it all. Feel free to pause the screen and check. It's same process we've done, except notice I'm calling this D sub x because it is the determinant, but I'm doing something a little bit special there with the x coefficients. So those are replaced. I've got this batch here of 20, -17, and 28 because again, pardon me, those come from our constant column right here. Why does this work? It's magic for right now, but it does indeed work. What we get eventually will be our determinant for, I'm going to call it again D sub x, which is -15. So here's where the awesome stuff really happens. You divide the D for whatever variable. This could be, for purposes of what we're doing right now, x, y, or z, by the determinant of the whole matrix to solve for the variable. So I take the determinant of d sub x, and I divide it by the determinant, d. And that will give us x is equal to negative 15 over 15, which means that x is equal to negative 1. And you've solved just for one variable. You haven't even solved for the others yet. Now, how do you solve for the others? You have some options. I would say just practice using Cramer's rule for right now. But we're basically able to do the same thing, except, these are my y's. So I just plug in, again, I take out the coefficients for y, and I plug in. And eventually I'm going to look for d sub y over d, the determinant, for the respective determinants. If I want to find z, I do the same thing. I take from my constant column, I substitute for the coefficients of z, and then that gives me z is equal to d sub z over d. That's it. You can actually find just one variable. You don't have to cancel out everything and plug back in. It's kind of cool. It's always going to be some process to go through these because there are a good amount of calculations involved, but this is another tool that you've got, particularly handy if you don't need to solve for everything and you just want to find for one. So review this, ask the questions that you have when we get back together, and have a great day.